Welcome to this lesson session titled Tutorial Lesson 3 with Was Moses, a mathematics teacher. In this lesson, we shall be looking at application of the inverse and identity properties of real numbers to solve simple linear equations. As lesson objectives, it is expected that at the end of this lesson, learners should be able to state the additive identity element of real numbers, state the multiplicative identity element of real numbers, state the additive inverse of every given real number, state the multiplicative inverse of every given real number, define any simple linear equation in one variable, solve all types of simple linear equation in one variable. We are going to be studying this lesson by a presentation as follows. The identity and inverse properties of real numbers. Before we go into the lesson proper, we need to first of all understand what the identity and inverse properties mean. The identity and inverse properties of real numbers are defined for two operations, namely the addition and the multiplication. For the identity property, first, we look at addition. Addition, for any given number A, there exists 0 such that A plus 0 is equal to 0 plus A, which is equal to A. Multiplication. For any given real number A, there exists 1 such that A times 1 is equal to 1 times A, which is equal to A. Now, since all real numbers satisfy these two conditions, we say that 0 is called an additive identity element, while 1 is called a multiplicative identity element. The next property is that of the inverse. Again, we look at addition. For any real number A, there exists another real number, negative A, such that A plus negative A is equal to negative A plus A, which is equal to 0. Multiplication. For any real number A, there exists another real number, 1 over A, such that A times 1 over A is equal to 1 over A times A, which is equal to 1. And again, since all real numbers satisfy these two conditions, we say that negative A is called the additive inverse of any real number A, while 1 over A is called the multiplicative inverse of any real number A. We now use these two properties explained above to solve simple linear equations in one variable. And to do this, we need to first of all recall what a simple linear equation is. A simple linear equation in one variable is an equation of the form ax plus b equals c, where a is the coefficient of x, b is a constant, x is the variable, and c is the result when ax combined with b. With the real numbers a, b, and c always given, which means that in every given linear equation in one variable, what you're looking for is just the variable. A, B, and C will always be given. Now, when you solve a simple linear equation, the solution to that simple linear equation is always the value of the variable. And that solution is called the truth value. To better understand this lesson, we are going to be looking at solutions to these given examples. Solve the following simple linear equations. 5x plus 7 is equal to 12. 2y minus 3 over 5 is equal to 1. X minus 5 is equal to 3x plus 10. 5x over 3 plus 20 is equal to 0. 2 into x plus 5 is equal to 8x plus 1. Now, before we go into solutions of those examples, we should first of all look at the rule used in solving simple linear equation, which is to solve any given linear equation in one variable, rearrange it in the form ax plus b equals c. Then, when that is done, you check the following. We use the additive inverse to remove any constant b, and we use the multiplicative inverse to remove any coefficient a of the variable. When these two are already in mind, we now look at the solutions to the given examples above. A says 5x plus 7 is equal to 12. We add the additive inverse of negative of 7, which is negative 7, on both sides. And if that is done, 5x plus 7 plus negative 7 will now be equal to 12 plus negative 7. 7 plus negative 7 gives 0, which is an identity. So this reduces the constant to an identity 0. And when we have 5x plus 0 is equal to 12 plus negative 7 reduces this to 5. The identity 0 simplifies the right-hand side to 5x, because the identity leaves any real number unchanged. We have 5x is equal to 5. Now, how do we do away with this 5 to make x the subject? We now use the multiplicative inverse of 5, which is 1 over 5, and we multiply it on both sides. One over 5 times 5x is equal to 1 over 5 times 5. The coefficient of x reduces to an identity 1. And the right-hand side too simplifies to 1, giving 1x equal 1. And 1x gives x, since 1 is an identity element, giving us our truth value as x equal 1, which is the solution to A. We move to the B part of the example. 2y minus 3 over 5 equals 1. Again, it is in the standard form. We add the additive inverse of negative 3 over 5 on both sides. And this additive inverse is 3 over 5. 2y minus 3 over 5 plus 3 over 5 equals 1 plus 3 over 5. This reduces the constant, this constant like this, to an identity 0. And that identity 0 will leave any number on the left-hand side unchanged. That is why we have 2y is equal to, and to simplify the right-hand side, a whole number and a fraction, we simply multiply 5 times the whole number. We add the numerator and we maintain the denominator. This gives us 8 over 5. Now we need to remove the coefficient of y. And again, we said to remove the coefficient of y, we multiply both sides by the multiplicative inverse of 2. And what is the multiplicative inverse of 2? 1 over 2. So we multiply both sides by 1 over 2. 1 over 2 times 2, y is equal to 1 over 2 times 8 over 5. And again, multiplying 2 by its multiplicative inverse gives an identity 1. The left-hand side reduces to 1y. And the right-hand side simplifies to 2 goes here, 1 into 8, 4. Simplifies to 4 over 5. The coefficient of x reduces to an identity 1, as we've said, giving us y equals 4 over 5 as the truth value of this result. Now, looking at A and B, we've seen that there are some shortcuts we can do. We've seen that dividing both sides or multiplying both sides by a multiplicative inverse in a case where that coefficient is a whole number is simply the same as dividing both sides by the coefficient. So that is why we say we conclude from A and B that for whole number coefficients, simply divide both sides by the whole number. We move to C. X minus 5 is equal to 3x plus 10. It is not yet in the form ax plus b equals c. So we rearrange it in that form by collecting like terms using the additive inverse of negative 5 and 3x, and we simplify. These arrows will indicate the row. You see, negative 5 goes here and 3x will move over, meaning that when you add the additive inverse of 3x here, it moves across. And when you add the additive inverse of negative 5 here, it moves across because it dissolves the left-hand side. Okay. When that is done, we have x minus 3x equals 10 plus 5. And simplifying gives us negative 2x equals 15. Again, at this level, we need to do away with the coefficient of x. And how is that done? We said that for whole number coefficient, simply divide both sides by the coefficient of x. So in this case, we're just dividing both sides by the coefficient of x. And the coefficient of x is negative 2, divide both sides by negative 2. Negative 2 cancels, giving an identity which leaves x unchanged. And 15 over negative 2, nothing can cancel, which leaves us x equals negative 15 on 2. That is the solution to C. We move to D. Now in D, it is almost in the form ax plus b equals c. But when we look at this, we see that the coefficient of x cannot clearly be read at because it's neither 5 as the coefficient of x since there is a division by 3. So what we do is we note that 5x over 3 is the same as 5 over 3, all that into x. And in this one, we see that the coefficient of x can be clearly taken out as can be seen here. In the standard form now, we remove 20, which is the constant, by subtracting negative 20 on both sides. So we've seen that adding the additive inverse of 20 is the same as subtracting 20 on both sides. So we subtract 20 from both sides. And when that is done, the left-hand side reduces to 5 over 3x, while the right-hand side gives negative 20, because 0 minus 20 gives negative 20, which simplifies to 5 over 3x equals negative 20. And now, to remove 5/3, which is the coefficient of x, we multiply both sides by the multiplicative inverse of 5/3. And the multiplicative inverse of 5/3 is 3/5. When this is done, the left-hand side reduces to 1x, which leaves x unchanged. And the right-hand side can be simplified by 5 here, 1, 5 into -20, -4. -4 times 3 gives -12, giving us x equals -12. And here we have noticed something. Multiplying both sides by the multiplicative inverse of a fraction simply means we are multiplying both sides by the reciprocal of that fraction, because for any fraction, the multiplicative inverse is the reciprocal. Clearly here, we say multiplicative inverse of any fraction a/b is also called the reciprocal of that fraction and is given by b/a. And to find the reciprocal of any given fraction, just invert the fraction. The denominator becomes the numerator, while the numerator becomes the denominator. We move to the last part, which is E. 2 into x plus 5 is equal to 8x plus 1. Here it is not in the standard form of a simple linear equation. So we first expand the left-hand side. That is the side 2 into x plus 5 by using the distributive law. Meaning we first take 2 multiplied by x. After that, we take 2 distribute over 5 multiplying by 5 to give 2x plus 10 is equal to maintain the right-hand side, 8x plus 1. Now, in this case, we collect like terms. We rearrange in the form ax plus b equals c by collecting like terms and simplifying. Again, we take 8x and we send it this way using its additive inverse, meaning we'll add -8x on both sides to give 2x minus 8x on this side, because here it will drop to 0. And we add the additive inverse of 10 on both sides. That is subtracting 10 on both sides, giving us 1 minus 10. Simplifying gives 2 minus 8 is -6, and 1 minus 10 is -9. So -6x is equal to -9. And we said that when the coefficient of the variable is a whole number, we simply divide both sides by the coefficient, that whole number. So we divide both sides by -6. And if that is done, the left-hand side reduces to an identity which leaves x unchanged, while in the right-hand side, negative cancel, 6, 3 goes into 6, 2, 3 goes into 9, 3, giving us x equal 3/2 to be the truth value of this result. And that gives a solution to the simple linear equation in one variable, which lead us to the end of the lesson. Thank you all for viewing. And if you did enjoy the lesson, don't fail to subscribe, like, and share. And always be there for our subsequent lessons, because there will be more interactive lessons. And before any lesson, the title of the lesson and the objectives will always be communicated to you. Thank you for viewing.